Good morning, everyone. I hope you're well and you're staying safe from the storm. So today is our lesson on something called convection. Now, before you watch this video, you should have done a worksheet which I attached to Google Classroom. It's a worksheet you can see on my screen now. Now, what I'm going to do during this video is I'm going to talk you through the answers to the worksheet. Now, I know you might have written your answers on a piece of paper because you might not have printed the worksheet. That's okay. I also know I have your books. They're sat in my classroom at school, so everything you do today will be on paper. I know that's not an issue, don't worry. But as I say, I'm going to talk you through the answers to the worksheet. I'd like you to mark your answers for me, please, with a different colour pen. If you have any questions, if anything I say doesn't make sense, or you just want a bit of clarification, please feel free to message me. And the best way to message me is probably by email. I'll pop my email on Google Classroom so that you can send me an email, just because notifications on Google Classroom tend to get a little bit lost otherwise. So anyway, enough of that. I'm going to talk you through the answers. I'm then going to go on to the notes for today. So, first one. What units are used for temperature? Now, the most common units that we use for temperature are degrees Celsius. I mean, I can just show that with a little circle up there and a big C. You may have also written a K. Now, that stands for Kelvin. Now, please remember that's Kelvin with an L, not just Kevin. That's another unit that scientists use. Now, I know also that Americans use Fahrenheit. I'm not writing that down because as scientists, we don't tend to use it. I know it's a unit for temperature, but we don't use it in science. So as I say, the main ones are degrees Celsius or Kelvin. What instrument do we use for measuring temperature? It is the thermometer. Now, if you're not sure about how to spell it, it is thermometer. So thermometer is a thermometer, as in a temperature meter. That's where we get the name from. Then you had to look at the diagrams and tick. Ooh, I was trying to scroll there, not draw. Hey ho. Oh, there we go. You had to look at the diagrams and tick one of each pair that has the most thermal energy stored in it and explain your answers. So 2A would be the large bowl of porridge at 30 degrees. The reason the largest one has the most energy in it is because it has the most particles. So you here are comparing two bowls. One is a small bowl, one is a large bowl, but they're both at the same temperature. The large bowl has more particles in it, so it will have more energy. So more particles equals more energy. Okay, let's have a look at the next one. You have a small pan of soup at 80 degrees and the same size pan of soup at 50 degrees. And again, you're being asked to work out which one has more energy. And the answer is the small pan of soup at 80 degrees. Why? Because a higher temperature equals more energy. Now, I know I'm writing very quickly and I'm not putting full sentences. In an exam, please actually write in a full sentence, but I want to go through this fairly quickly so we can get on to our next task. So, next one, look at these two bowls of food. You've got 300 grams of soup at 80 degrees, the air temperature is 20, and then you've got 300 grams of ice cream at 2 degrees. And the questions ask, will energy flow into the soup or out of it? Now, it will flow out of the soup. Why? Because it does say explain your answer. Because the soup is hotter than the air. And energy always goes from hot to cold. Hot to cold. Next one, 3B, will energy flow into the ice cream or out of it? Now this time it will flow into the ice cream. Explain your answer, because the ice cream is colder than the air. And as I've just said, energy always flows from hot to cold. So I won't repeat myself for that answer, but that is it. Right, and our final question was, sweating helps you to cool down. Which process is involved in sweating? Tick one box. It is evaporation. If you remember, we did a lesson on that a couple of weeks ago, so if you can't remember much about that, go back and have a look at your lesson from then. So that was the answer to that worksheet. And as I say, if you have any questions, please feel free to send me an email and I will get back to you with any answers or clarification. Now we're going to go on to the notes for today. Now I'm just going to open this. Today we are looking at convection. Now as I go through this PowerPoint, what I would like you to do is pause at various points and write the notes. I will show you what on each slide you are going to want to write down. So that way you'll get all the notes in your book, or actually on paper, I have your book. But as I say, you can just pause the video and write the notes. So let's just have a quick reminder. Last lesson, we looked at something called conduction. Now, conduction was where heat was transferred through a solid. So you had particles that couldn't move around. They were all rigidly next to each other, but when one of them got hot, it started vibrating, and then that would pass the vibrations on to the next particle and so on. Now, convection is slightly different. Convection is a transfer of heat energy by moving particles, as in particles that can actually move around. They are not stuck in one place and just vibrating, they're moving. It only happens in liquids and gases. It can't happen in solids because, as I said, the particles can't move around. So convection is the transfer of heat energy by moving particles. Can you please pause the video and write down these couple of sentences? Okay, assuming everyone's done that, let's move on. We're now looking at how it actually works. Now let's have a look at the diagram before I talk about the notes on the left. On the diagram on the right, you have something like a beaker of water on a Bunsen burner. And at the bottom there, you have a heat source. So let's all imagine perhaps that there's a little Bunsen burner underneath there. Now that heat source is causing the water immediately above it to get hot. I'm assuming it's water in this beaker. When the particles get hot, what they do is they get something called less dense. That means they float up. So when things get hot, they rise up. And you can see the arrow from the middle there pointing up. That's that hot particles going up. Then they get to the top of the beaker and they're no longer near the heat source. So what happens? They cool down. And so those cooler particles then sink back to the bottom. So you can hopefully see you've got this little cycle going on. You've got going up where it gets hot in the middle and then it cools down and it sinks back down. And we call that a convection current. So when things get hot, they rise up. Now let's have a little look at the sentences I wrote on the left. When liquid or gas is heated, hot particles rise up. When they reach the top, the particles cool and sink back down again. This causes a convection current. Now, what I would like you to do, please, is you are going to write those few sentences and you are going to draw me that diagram, please. So pause the video, do that. Okay, and the final bit that you are going to write and do me a little drawing of is a use of convection. Hot air balloons use convection to rise up into the sky. So the idea is that they are heating gas, the gas becomes hot, it becomes less dense, so it rises up, and that's why hot air balloons can actually fly, because the gas inside is hot, so it's less dense, so it tries to go up. If you want a hot air balloon to come back down, what they will do is stop heating the gas. The gas will cool down and it will sink again. So I'd like you to write that one sentence and draw me that hot air balloon, please, or a hot air balloon, doesn't need to be that one. Now, that was all our notes for today. Your next task, which I have explained on Google Classroom, is you are going to make me a poster just comparing our last two lessons, conduction and convection. Now you can do this on your iPad or you can do it on a piece of paper, either is fine. I would like you to submit those posters to me through Google Classroom. Okay, so I do not want them emailed, I want them through Google Classroom. Now to do that, if you are not sure, you look at this lesson and you will see the fact that there is an option for student work where you can submit a picture or a file. So if you are not sure, please let me know, but Google Classroom is the way to do it. Right, that's everything. Please let me know if you have any questions. I'm always here to help, but if I don't hear from you, have a fabulous half term. Bye everyone.